Hi, I'm Eli Hatcher, and I predicted when a book was written based on its text. To do this, I used natural language processing and regression, which are both branches of machine learning. I took books' texts from Project Gutenberg, and I put them all in an Excel spreadsheet with their publication dates, which I use as a proxy for writing. So the first thing I had to do once I had my data was to clean it. And cleaning is the first step for anything you do with natural language processing because natural language is messy. And if we don't clean it, that can result in the words good and good being registered as different words by the computer when we really want them to be the same word. So I removed all the capitals and I removed all the punctuation. So I only had lowercase letters. The next step was stemming. So stemming is an important part of natural language processing because it takes words such as go, goes, going, and turns them all into one word, go. And that's important because they all go, goes, and going. They all express the same idea, but the computer doesn't know that because they're all spelled differently. So stemming takes it down to its main idea, go, so that the computer doesn't say, okay, go is substantially different from goes, because it's not. Finally, I could then use my bag of words model to convert the text into a vector of numbers. And the way it did this was for each word, it had a slot in the vector. And for that slot, the number there was how many times that word showed up in the text. So for example, in the sentence, the dog ate the food, the would have 2, while the other words, dog, ate, food, would have 1. And if we have other words, say phone or computer, those would have zeros because they didn't show up in the sentence at all. Once I converted my texts into numbers, I could then use almost any regression technique I wanted to predict when the books were published. I ultimately decided to use random forest, which is an ensemble method of decision trees. Basically, instead of having one decision tree making the choice, you have a bunch of decision trees, all based off slightly different subsets of the data. And then you take the average of what each decision tree says, and that's your answer. So it's more stable than a single decision tree and less prone to flukes in the data. After I decided to use random forest, I then split my data into a training set and a test set, and then I ran my model. And my results were pretty decent. I had a median error of 75 years, which means that about half of my errors were less than 75 years and half were more, potentially way more. I hope you enjoyed this video. If you want to see more, subscribe to get my next videos. You can also check me out on LinkedIn or Medium, both links of which are in the description. And finally, follow my newsletter for monthly updates on what I've been up to. Thanks!